All right. So we're going to head straight into Module 2, and today we are going to be doing some coding. I assume that PyCharm is still not installed on these computers. Has anybody checked for that? They didn't tell me. I put a support ticket in, but they did not say that it was done, so I assume that means it's not done. That's okay. Go ahead and log in anyway, and you can open up a web browser, and we're going to use online Python for coding in this class session. We can use that instead of PyCharm until PyCharm gets here, as long as it doesn't take too long. So today we're going to jump into some fundamental things about programming. It's going to feel like a lot of information, but it's not too scary. It's really just sort of laying down the foundation for some of the stuff we're going to keep talking about in the next few weeks. But before we even get into that, I want to give you a little bit more information about Python, about what it is, how it works, why we have Python, that sort of thing. Okay, so first of all, the name. Now, you commonly see a snake associated with Python, but in fact, the name Python was inspired by something that is not a reptile. Maybe you've heard of it, but let's see where it came from first. So this is Guido van Rossum. He was working in the late 1980s, not a computer guy, really, just more of a generic science nerd, but he was doing scientific work using computers to analyze data. And he was using a language that was actually called ABC. We don't really use it anymore. But he was working using this language, and what he discovered was that that language wasn't allowing him to do a lot of the things that he wanted to do very easily. And so what he decided to do was create his own language. And you'll see, if you go back into computing history, you're going to see a lot of that sort of thing. Like, oh, this thing doesn't exist. I'm just going to build it for myself. In fact, when Steve Wozniak and Steve Jobs sat in their garage and made the first Apple computer, it was because a computer like that just didn't exist, and they thought, hey, this would be really useful. So they just built it. That's how computers and computer languages and operating systems, Linus Torvalds, when he created Linux, created it because he wanted an operating system that worked a certain way, that did a certain thing. He just created it. That's where a lot of this stuff comes from, is just sort of scratching your own itch, but then realizing, hey, this is really useful. So Guido van Rossum, great name, by the way, created Python, and he named it not after his favorite snake, but something else. If this image is familiar to you, then you probably enjoy some of the same kind of movies that I do. What I find is that people either love this kind of humor or they hate this kind of humor, right? There's not a lot of middle ground with this stuff, but this is Monty Python, and it is the title screen from Monty Python and the Search for the Holy Grail. Some of the corniest effects and jokes that you've ever seen, but also pretty funny if you have a certain kind of humor, like I said. He obviously did and enjoyed this movie so much that he named an entire programming language after Monty Python. But what's so great about Python? The first thing, and probably the reason that this class even exists, is that Python is easy to learn. And that's a really, really good thing for all of us, because what it does is it makes learning how to program and how to think like a programmer more accessible, because the language itself isn't a barrier. And one of the main reasons that Python is easier to learn is because when you're typing commands in Python, you're using a much more natural language. What I mean by that is that if you take somebody else's Python code and you start reading that code, you're going to see things that make sense, like file open or print or whatever. The commands in Python are often words that make sense given what they do. And that's sort of an emphasis as we create Python programs of our own, is making them easily readable so that if somebody else looks at your code, they should be able to read it. Now, if you're going to be a software engineer or a computer scientist or anybody who creates programming code for a living, 99% of us don't just sit in our dark room by ourselves making programs that nobody else reads. 99% of the world of computer science and software development, you're going to be working in teams, often sharing the same code. So being able to write code that other people can read and that makes sense at a face value is one of our fundamental skills of software development. So Python is great because it's going to help teach us that. The other things that are great about Python, number one, it's versatile. What that means is you can do all kinds of things with Python. It's very, very flexible, and it's a big language set that can do a lot of different things that are really fun. And I'm going to talk about some of those in just a second. The other thing, though, is that whatever things that Python can't do, you can make it do by extending the language. What that means is if there's not a command or an ability that Python has, you can actually create it and add it to Python. And that's really cool because what that means is that not only can Python already do a lot of things, but these user-created modules for Python are often just shared for public free use online. So if you want to use Python to control a drone or a robot or power your solar-powered dog feeder or whatever you can dream up, you can probably use Python to do that. So it makes it really great. And a lot of times, those things already exist in some form out there so that somebody else has done it for you already. And that brings me to the last great thing about Python is because it's so popular, right now it is, and it has been for almost a decade, the world's most popular programming language by number of users, bless you. Python has lots and lots of users out there coming up with all kinds of creative ideas and sharing those ideas for free online or sharing their solutions to problems online. So that's really great. If there are tons of people using it and it's sort of a culture of sharing your information, then there's lots of great information out there and great ways to learn how to use Python or do really amazing things with it. This is just a partial list of some of the biggest companies in the world that are using Python in a production capacity. Google, Netflix, Dropbox, Spotify, you probably recognize a few of these. One that's not on here that I think is kind of funny is Microsoft. And Microsoft it's a funny thing that they use Python in production code because Microsoft actually has built multiple of their own programming languages and tools. C++, C#, J#. Those are Microsoft properties, basically. Not C++ necessarily, but Microsoft is very deep in those particular languages. But here they are using Python because Python, in a lot of situations, is the fastest, easiest, cheapest way to roll out a solution. So even Microsoft, who has their own languages, chooses to use Python instead. And this is just a small sampling, like I said, but these are big companies. And notice OpenAI down there at the bottom. 99% of all AI development is happening in Python. So if you're interested in AI or developing AI or working in AI, Python is a basic prerequisite. Okay, so my son who works in AI and does research in AI primarily programs in Python. So what can you do with Python? This is just a partial list. Web development, data science, machine learning and AI, of course, robotics, game development, scientific computing, databases, embedded systems, and Internet of Things. If you don't know what an embedded system is, then go to Home Depot and look at the new refrigerators. And what you're gonna see on the refrigerators that I never would dream of seeing on a refrigerator growing up is what? Screens. What the heck? And believe it or not, Many of those refrigerators now, this is the worst part about it. You have to pay to turn off the advertising on the screens on your own refrigerator. How stupid is that? What's the benefit of the screens? So you can walk up to your refrigerator and see what the weather's going to be before you pour yourself a glass of orange juice. I don't know, um, but that's what an embedded system looks like. You could make a toaster oven that's connected to the internet, so that when you wake up in the morning to your alarm clock, it makes your toast for you. Is that possible? Absolutely. Can you do it with Python? You bet. Has somebody done it? Probably. But I mean, just because you can doesn't mean you should. But some of that stuff is just a fun exercise in like seeing what's possible. So I would encourage it from that perspective. Now, this is an important technical piece of what you need to understand about Python, because it represents both an advantage to Python and a disadvantage. When we create our programs in Python, they're just text files, right? You can edit them using any text editor. You don't have to use PyCharm. PyCharm does some things for us, like it allows us to check our syntax, to do debugging. It allows us to run those files immediately. But this is just a text file with the letters py after the dot, so that Python knows that this is a Python file. So this allows your computer to associate Python scripts with a program called Python. Now, Python is a program that does something for us, and it's why we have to have Python installed on a computer in order to run our Python scripts. Python is what we call an interpreter. So when we run our Python scripts, it's actually sending that script to Python. And what that Python interpreter does is just like any other interpreter, except the language it interprets to is from Python, our programming language, to the native language that's spoken by the computer. Now, Python interpreters are a lot like other interpreters in that it's nice because I don't have to learn how to speak the language of my computer. I can just learn this Python language, which is much easier and quicker to learn. So if I was speaking to a group of students, let's say all you all spoke was French. I don't speak French. I speak only English and a tiny bit of Spanish. But that doesn't help me with French, does it? So we'd have to have an interpreter in here. Have you seen somebody speak to a group through an interpreter before? What does the speaker have to do when they're working with an interpreter? Wait. Exactly. So I say something in English. The interpreter is standing here next to me. I say it in English, and then they listen to me in English, and they repeat what I say in French. And then if we're having a conversation, somebody out here would say something in French, the interpreter would listen, and then they would speak to me. Now, I want you to think about how that's fundamentally different than what I'm doing right now with you all, because I'm speaking a language, English, that you all understand at least at some level, right? So you're understanding what I'm saying, I'm understanding what you're saying. It's a faster interaction than when I have to speak through a translator that goes to you, that goes back to the translator, then back to me. So it has more steps. And that's exactly the downside to Python, is that it's an interpreted language. That's exactly what it means. You're typing Python scripts, you're running them, Python talks to the computer, talks back, and then spits out the result. Other languages, like C++, are what are called compiled language. Okay, and a compiled language, you write it in C++, and there is no C++ program, there's a compiler. But what the compiler does is it takes the whole thing and it turns it into a compiled program that is in the language the computer speaks. So it's like if I was doing a compiler version of the translator scenario, I would just go learn French. so that I could speak directly to you. That's the difference. So the benefit of Python being an interpreted language is that I only have to edit this file, and then I can run it. Edit, run, edit, run, edit, run. If it's a compiled language like C++, I edit the file, compile it, and then I test it. And if something's wrong, I edit it, compile, test. You can see that when I'm developing and creating the software, that the process takes longer. But when I'm running the software, it's a little faster when I'm compiling it. In fact, a lot faster. You're just not going to notice it because on our computers, the programs that we're writing in Python are pretty small. They're pretty basic. And so everything we write in Python is going to feel, wow, that was really fast. And I'm going to show you how fast in the next couple of modules, how fast a Python program actually runs on a computer, even a computer like mine that's about 5 years old, which is ancient in computer terms. Although some people have older computers, right? We all have, I've got a few Macs that are that old sitting around too. So even on a slow computer, a Python program feels like it's going to run fast. So what's the big deal? Who cares if it's 1 millisecond versus 2 milliseconds to run a program? Well, we don't care about that in this scenario where we're running desktop programs that are doing very basic things. But if you're Google and you're using Python to do something on your website where it gets millions of visitors every hour, then that program is running so much more that difference in just the electricity usage between Python and a C++ program that does the same thing could cost you millions of dollars a year. So there is a difference, but only at a huge scale, only if the program is very, very busy. On our desktops here, we won't know the difference. Even if we're creating like a very intricate program or a game with lots of characters on screen, we won't know the difference. It's fast enough using these computers that we don't have to worry about it. But just know that when we talk about Python, a high-level language is the same thing as saying an interpreted language. It doesn't mean you're a higher level like you're the boss. It means you're a higher level like you're further away from the computer's hardware. A compiled language or a low-level language like C++ runs straight in connection with the hardware. No interpreter necessary, but you have to compile your programs. So that's the difference.